Going to do lesson 1.2b today, and we're going to continue talking about functions and graphs of functions. Functions and graphs. And we have three parts, A, B, C. So yesterday we talked about even odd functions. We talked about function notation, domain range, all that stuff. Today we're going to do piecewise functions. A lot of people hate those. We're going to do absolute value and composition of functions. Remember FOG? F of g of x, g of f of x. Yeah, it's composition of functions. Functions within functions. All right, so here we go. First part, letter A. Let's do some piecewise graphs to start off with. You don't need to use your calculator. Is that how you spell piecewise? It looks so wrong. Yeah. Okay. Piecewise, they're just different pieces of different types of graphs usually. You graph one piece, you graph another piece. There's some piecewise, that kind of piece, P-E-A-C?
No, it's not.
No. Sometimes they're connected, which means that they're continuous. Sometimes they're not connected, which means they're discontinuous. Yeah. So let's go ahead and let's do one. Number one. And we're going to graph. And I'll show you how to do them on your calculator if you really want to see that. Let's suppose that we have f of x equals bracket. And we have three parts to this piecewise graph. We have negative 2x when x is less than 0. And we have x when x is between 0 and 1 and equal to 0 and 1 also. And then this function is a parabola when x is greater than 1. So it's got three different pieces to it, three different graphs. That's why you hate them, right? Because it's three problems in one. Yeah, it makes you look like, oh, I assigned one problem, but there's really three things to do. So you can graph these by hand. If you are going to graph by hand, you just make three little tables, or you can, like if you look at the first one, you know that this one has a y-intercept of 0, but there's actually not a point there because x is less than 0. But if you were going to do a t-chart on the first one, I would choose 0 as a number to plug in. You want to always choose the boundaries. Even if it's not equal to 0, you want to choose 0. You plug it in and you get 0, and then you make an open circle, not a closed one, because it's not included. Now, the rest of the values that you can choose are going to be less than 0. Or you can just look at the slope. The slope is down 2 and over 1. Okay? So I could choose negative 1 if I wanted to. And if we choose negative 1, my graph's wrong on my paper. If I choose negative 1 for x, what do I get? I get positive 2, right? Positive 2. So this would be down 2, and then really to the right 1. So I might want to go up 2 and to the left 1. It's a negative slope. And that's one piece of my graph. The other piece is just simply x. Y equals x is the diagonal. It's the parent function for linear equations. And this one is between 0 and 1. And so it's just going to be this little segment in there. The diagonal, just the part from 0 to 1. If you wanted to and you weren't sure what that was, you could pick 0, plug it in, pick 1, plug it in. It's just whatever y is, x is. And the last part is a parabola. And so what I would do for the last one is I would still maybe make a t-chart, plug in 1. When you plug in 1 and you square it, you get 1. So there's an open circle there, which you don't really need because it's already filled in. And then if you plug in 2, you get 4. Okay, and you know to make it curvy because it's a parabola. So you get a ray on this side, you get a segment in the middle, and you get a piece of a parabola. And it's a piecewise function. All right, I'm going to pause the video and show you how to do it on your number 2. Now let's go the other way. How about I give you a picture of a graph, and you have to come up with the function that it goes to. Yeah, a little harder. Okay. So let's put some specific points in here. We have the point -2, 0. And we have the point 0, 2. And let's say that our graph goes through those two. And then 1, 2, 3, it goes straight for 1, 2, 3. And then it goes through 4 here. Woo! And that's connected. It's hard with the stylus though. And it goes through that point right there. And that point, and that point. All right, so we need to come up with our own piecewise function for this graph. So what you should do is you should look at the graph and go, oh, there's 3 pieces to it. I'm going to have 3 functions for this graph. And they're pretty easy. They're lines. They're all lines. You can find equations for all of them. F of x is equal to, give yourself a bracket. And over here, let's start with the first piece. Okay, this is when x is, and this is up to you actually. You can say x is less than 0, or you can say x is less than or equal to 0. But if you include 0 in the first piece, do not include it in the second piece because then it's not a function. It has 2 points right on top of each other. All right, so what is the equation of this line? What is the y-intercept? 2. And what is the slope? Down 2 over 2. So the slope would be what? 1, or you can say up 2 over 2. Slope is 1, y-intercept is 2. Okay, if you don't like that, because I can kind of tell some of you don't like that, you can take the 2 points that you see and make an equation of the line, which we did earlier last week. All right, so that's our first piece, x plus 2 when x is less than 0. Now how about that middle piece? Yeah?
Why is it when x is less than 0?
Because that's where x is 0 right here. So it's only for this part of the graph when x is less than 0.
Oh, right.
Yeah, you could say less than or equal to 0, but I'm going to save that for the middle portion. So the middle is the equation what? Y equals 2. Yeah, it's just y equals 2 for the middle part. So I'm going to say that f of x is 2 when x is between 0 and 3. And I'm going to include both of them on that. Less than or equal to 3. So between 0 and 3, including both 0 and 3, because this graph is continuous. There's no holes in the graph. You have to have it equal to 0 and 3 at some point. You could have split it up, though. And then the last part will be this last part over here, when x is greater than 3, not equal to 3 because I've already included it in the middle portion. And so this one, you might want to take your 2 points and put them in to find the equation of that line. We can tell what the slope is, right? Slope is down 2 over 1. So our slope is -2. And I can just take 1 point. Let's take this point right here. This is the point 4, 0. And I can make an equation with that by using point-slope form. So I can go y minus 0 equals -2, x minus 4. We did all this last week, so you should be pretty good. And then you get -2x plus 8. So if you were to follow that graph all the way up, it would cross that 8 way up there. And that's your formula, your function for that equation. Okay, so that's piecewise. Hopefully you don't hate it too much this year. Did you guys in RAM, did you do that last year, piecewise graphs? No? Okay. We did in HAM, so. All right, then we have absolute value. Absolute value. So you guys all know the absolute value function, f of x is equal to the absolute value of x. That's your basic parent function. The absolute value graph is that even, odd, or neither, just this basic parent function. Even, odd, or neither, which one? You don't remember? Do you remember the shape of it, what it looks like? It's a V. So is that graph even, odd, or neither? Even, okay. So this basic parent function, absolute value, is an even function. You can also write it as a piecewise function. This is the graph of f of x. And it is simply just x, the diagonal, when x is greater than 0. And it is negative x when x is less than or equal to 0. So that's a piecewise function. It's much better as just the absolute value function, but you can write it with the piecewise. And what we're going to do is we're going to graph the translation of this without a calculator and find domain and range, no calculators at all. So number 3. Let's take f of x equals the absolute value of x minus 2 minus 1. Okay, so hopefully you were pretty good at this last year, right? Translating functions. They all work the same way. Did you notice that? Whether it's a parabola or a cubic function or a radical, anything. They all work the same way. You shift the opposite direction when it's inside with x, left and right, and you shift the same direction up and down if it's on the outside. So this one right here, you start with your parent function, and you're going to shift it. We're going to shift it 2 to the right, good, and 1 down. And this is just your basic slope of 1, up 1 over 1, but it is a V shape. So make sure that you graph both parts. And that's it. Pretty easy. I mean, look how complicated it is. You can do that all without a calculator. And let's go ahead and find the domain and the range. Domain you're going to like for absolute value. Are there any restrictions at all to x? Anything you cannot plug into an absolute value? Not at all. All real numbers, that would be the domain. Now the range, that's going to be limited. When things come out of this function, they're going to be positive and minus 1. Positive or 0 and minus 1. And so if you graph it, you can see that your range is going to be what? Perfect. Greater than or equal to negative 1. If you want to write it like that, you can. You can also write it as negative 1 to infinity in interval notation. All right, let's do one more of those. And then we'll move on to the last part. I know it's a lot today, huh? G of x equals, yeah, it's all stuff you've already learned, huh? Negative absolute value x plus 3 plus 4. Same thing. I'm going to graph by hand, domain and range. Do you want to try this one, or do you want me to walk you through it?
Let's try.
Oh, good, Trevor. Yay. Shout out to Trevor on the video. That was gross. I won't ever do that again. Yeah.
What will it reflect over the x?
If the negative's on the inside of the x, yeah. Okay, so we're going to shift 3 to the left, 1, 2, 3, and 4 up. 1, 2, 3, 4. And for this one, I want to go down 1 and over 1 because it is negative. If you were going to do the whole reflecting thing, you would have to reflect first before you shift. Because if you went up here and reflected, you'd actually be down below. So, all right, domain and range. Domains, once again, all real numbers. And this time the range has a maximum, and it goes lower than that, so y would be less than or equal to 4. If you were going to write that in interval notation, it would look like this, negative infinity to 4. Interval notation is always smallest to biggest. So if you wrote 4 to negative infinity, that makes no sense. All right, last part, part C. That was part B, wasn't it? Okay. Part C is composition of functions. Composition of functions. And when you learned this in Algebra 2, it was super confusing, am I right? All the f of x, of g of x, and all that stuff. Yeah, I know. And then you did it again last year, and it wasn't as bad. And now you're going to do it again. It's not going to be that bad either. Okay, outputs of one function are inputs of another. That sounds so confusing already. But this is what it is. You have f of g of x. And a lot of people don't like it written that way. Looks like fog in a way. That should be a much smaller. It should be like a little circle like that. There we go. Okay, this is equal to f with g of x inside of it, like that. A lot of people like that way a lot better. So let's do some. Number 5. All right, suppose that we're given a couple of functions. We're given that f of x equals x minus 7, and g of x is the parabola x squared. And we'll just do some fun stuff. We'll just find what f of g of 2 is, and then let's find out what g of f of 2 is. Okay? Generally, it's not going to be commutative. In other words, you can't just switch them and they're going to equal the same thing most of the time. There are some rare ones that you can plug in, come out the same. So what you do is you take 2 and you plug it into which function first? G. All right. Take 2, plug it into G, and you get the output is 4. That output is now your new input for function f, and you do 4 minus 7, and the answer is negative 3. Okay, a lot of times in Algebra 2, I'll have kids that will give me 2 answers to this. There's one answer to this, and the answer is negative 3. Try this one. 2 goes into f first, and when 2 goes into f, you get 2 minus 7 is negative 5. Negative 5 goes into G and gets squared, comes out as 25. Beautiful. All right, one more.
All right.
Yeah, I feel pretty confident in your composition function skills here. Let's say that we're sticking with those same x minus 7 and x squared, and let's just do f of g of x and g of f of x. So no numbers this time, just strictly in terms of x. And we're going to plug them in. You can actually graph these on your calculator too. If you graph f of x is y1, g of x is y2. Yeah, but we don't need to do all that. Okay. So g of x, the entire function of g of x, which is x squared, is going into function f. So you're really doing f of x squared now. So x squared is getting picked up. This x that's in f of x gets taken out. X squared replaces it, and you get x squared minus 7, and there's nothing to do. The mistake that students will make is they'll multiply them. They'll get x cubed, okay? That happens all the time. All right, the other one is to take f of x now and plug it into g. So we're going to take x minus 7 and plug that into g of x. So you get x minus 7 and the whole thing squared.
Do you want us to
Yeah, FOIL that out. You know the shortcut, right? You don't have to actually write x minus 7 times itself and do outside inside. You can square the x. The middle term is going to be negative 14x. It's x times negative 7 times 2. There's 2 of them. And then the last term would be positive negative 7 squared, which is 49. And we done. And that was the 7-minute bell.